Let's complete an example problem for a single component system. Consider a log cradle with a weight W and assume there is no friction between the log and the V-shaped cradle. The radius is represented by the variable r, and the angle between the holder and the flat surface is represented with the theta symbol. We need to determine what the contact forces are at point A and B. Pause the video here to attempt the question on your own first. Let's set up a coordinate system with positive forces upwards and to the right, and positive moments counterclockwise. First, you have to know that the contact forces Ra and Rb are acting perpendicular to the two legs of the holder. Also, since there are no other horizontal forces in the system, the forces in the x direction must cancel each other out. Using trigonometry, we set up right triangles with the forces Ra and Rb in relation to the angle theta. We obtained that Ra cos theta will equal to Rb sin theta. We will write it as the sum of forces in the x direction with a positive direction to the right is equal to 0 is equal to Ra cos theta minus Rb sin theta. Rearranging this equation, we obtain Ra equals Rb sin theta over cos theta. Remember that the log has a weight W, and this acts through the center of the log. For the log to be in equilibrium, this downwards force must be cancelled by the upwards forces from Ra and Rb. Using trigonometry, we set up right triangles with the forces Ra and Rb in relation to the angle theta. We can obtain that the sum of forces in the y direction with positive forces upwards is equal to 0 and equal to Ra sin theta plus Rb cos theta minus W. We can rearrange the equation to have the weight W on one side and substitute Ra with the answer we obtained in the slide previously, which is Ra equals Rb sin theta over cos theta. We then multiply cos theta on both sides and factor out Rb from the right side. In trigonometry, the expression sin squared theta plus cos squared theta is equal to 1. So Rb turns out to just be W cos theta, and from previously, Ra equals W sin theta. Now ask yourself, is the principle of concurrent forces satisfied in this example? By drawing lines for the forces we have determined, we say they all intersect the center, so the answer is yes. The principle of concurrent forces is satisfied. In this week, we learned about how to analyze the skeleton of a structure and identified structures in various examples. We also went through the 5 steps when solving a problem and how to exchange complex shapes for beams. And finally, we completed a log cradle example in full.